9FB, reactivity. Okay, they've packed a lot of information into just this double page here, so I'm really going to try my best to summarize it well for you. Firstly, we're talking about the reactivity series. Now, the reactivity series is a list of metals in the order of reactivity. So to test if something is very reactive or not, we can see how it reacts with water, with oxygen, and with acids. And we could have various results. There could be no reaction at all, there could be a partial reaction, it could explode, it could set on fire. So we've got the whole spectrum that we're looking out for. So that's one thing we're thinking about on this page. Another thing is what the reactants and the products will be when these reactions happen. If you were going to write some notes on this part, I would say you want 3 boxes for the 3 different kinds of reactions that we can have. So 3 different kinds of reactions that you need to know about are reacting that metal with water, reacting that metal with an acid, or reacting that metal with oxygen. I'm going to use the same metal every time for our example, so I'm going to use sodium. So if we take our metal and we react it with water, we end up with a metal hydroxide and hydrogen. So if we have sodium and water, we'll end up with sodium hydroxide and hydrogen. Number 2, when we react a metal with an acid, we end up with something called a salt plus hydrogen. So for example, we could have sodium plus an acid and we'd end up with the salt that sodium makes plus hydrogen. This is our bigger box because the salt that sodium makes depends on the acid that we used. So let's add the acids in now. Let's fill in the gap. Sodium plus hydrochloric acid would make sodium chloride and hydrogen. Sodium plus sulfuric acid would make sodium sulfate and hydrogen. Sodium and nitric acid would make sodium nitrate and hydrogen. And your last type of reaction is the metal with oxygen. And if we have a metal with oxygen, we get a metal oxide. So with sodium, we'd have sodium plus oxygen equals sodium oxide. If the metal grabs onto that oxygen like it just did then, we call this an oxidation reaction. The last thing you need to know about on this double page is one practical way that we use the reactivity series to help prevent rusting. If we want to stop a metal rusting, we can attach to it another metal that is more reactive so that it reacts with the water and the oxygen around rather than the metal that we want to protect. This is called sacrificial protection. So for example, if a boat hull is made of iron or steel, we might surround it with zinc or magnesium, and the zinc or magnesium will react with the water and the oxygen around instead of the iron or the steel, and will sacrifice itself to keep the boat hull from rusting. The cons of this are that it can be expensive and you have to replace the sacrificed metals quite a lot. Okay, that's that double page done.